Trigonometric functions. Finally, we're getting to the reason you took this class, right? You just could not get enough of SOHCAHTOA and geometry and all those trig functions. We're finally there. But got to kind of put the brakes on it. We're going to go back and really define what trig functions are, and then we'll get to SOHCAHTOA in a future concept. All right, trig functions are defined by an angle theta in standard position and a point P having some coordinates, x and y, on the terminal side of the angle. Okay, let's pause and break that down. Here's the initial side, this green line of your angle. Here's your terminal side going through some point up there, we'll call it P. And this is your angle theta right here. So this is the angle that we're creating. We can find the distance from our origin from 0, 0 to r by using the distance formula. I think I meant to put a P here. So my distance formula, you've seen this before. We've got x1 minus x2 squared plus y1 minus y2 squared all underneath a square root. Well, I've got my point x and y, so that's what I'm using here. But the other point that I'm measuring between is my origin, 0, 0. So that's why I've put zeros in there. Just to note, this is actually derived from the Pythagorean theorem, so it might kind of look familiar. And eventually, we're going to rewrite this distance formula for r a little bit more simple. We're just going to take those zeros out because x minus 0 is just x anyways. Okay, now to define our trig functions. So we have let xy be a point other than the origin on the terminal side of an angle theta, just like we've drawn above. The distance is, again, r equals this equation. We've taken the zeros out because they're not necessary. And your 6 trig functions of theta are defined as followed. So sine of theta is y over r. So looking back up to my picture in the right, y is just the height of that line. So wherever my point xy is, it's the y coordinate. And r is your radius, is what it's standing for. Cosine is going to be x over r. And then tangent will be your y value over your x value. Cosecant, secant, and cotangent are just the equations above them flipped. So cosecant is r over y. We have a note here that y can't be 0. If it was 0, then we would be dividing by 0, which we can't do. Secant is just cosine flipped, and cotangent is tangent flipped. In this table, we're going to make note of when sine, cosine, tangent, and their cofunctions are positive or negative. So which quadrant they're positive or negative in. So, starting with sine and cosecant, we know that those use y and r from the definitions above. So r is always going to be positive. R is how long that line is, how long that line segment is between the origin and your point P. So r will always be positive. Y, however, will sometimes be negative. For example, if our angle was in quadrant 4, like I've shown here, then my y value would be negative because y's are always negative below the x-axis. So I'm going to put a negative sign for quadrant 4 sine and cosecant. Now, if we consider an angle that, say, lands in the first quadrant, that y value would be positive because it's above the x-axis. Likewise, if we're in the second quadrant, that y value is positive. And finally, if we're in the third quadrant, we know we'll have a negative y value. And just to elaborate on that just a little bit more in case it's unclear, I know that my y value here in the third quadrant is negative because all of these markings down here are negative y values. So just like we plot points in algebra, those are all negative y values. All right, I want you to pause your video and I want you to put in the positive and negative signs for the cosine and secant. So my x values are always positive over here, and in the other two quadrants, they're negative. Tangent's going to be slightly more tricky because we have both x and y to consider. So in the first quadrant, x and y are both positive. So when we divide two positive numbers, we're still going to have a positive answer. In the second quadrant, y is positive, but x is negative. So if I divide those, I'll have a negative answer. In the third quadrant, both x and y are negative. So if I divide two negatives, I get a positive. And in the fourth quadrant, y is negative, x is positive, so I'm going to have a negative tangent value. This little diagram down here kind of tells you what's positive. You know, in the first quadrant, all functions are positive. Second quadrant, sine is positive. Third quadrant, tangent, and fourth quadrant, cosine. A little way to remember this is the saying, all students take charge. All students take charge. So it kind of shows you A, S, T, and C, what's positive in which quadrant. Example, the terminal side of angle theta in standard position passes through the point 815. Find the values of the 6 trig functions of angle theta. Start by plotting the point, labeling the side lengths, and finding R. So the first thing we need to do here is graph it. We're going to plot the point 815 and draw our angle in standard position. The point 815, we're going to go to the right 8 units and then up 15 units. We don't need to draw hash marks or make this super detailed. Just kind of put the point where it would be about. Next, we're going to draw the angle. Remember, the initial side has to go on the positive x-axis, and the terminal side is going to go through the point 815. Now we can draw the triangle that was made here. And we need to start by finding our x, y, and r values. Our x value is 8, and our y value is 15. Those values came from our point. To find the r value, we're going to use the formula that we looked at earlier. Plug in your values for x and y, your 8 and your 15. And then plug that in a calculator. Now, using the definition of the trig functions above, we can just fill out our table here. Sine of theta is going to be 15 over 17 because it's y over r. Cosine of theta, likewise, is 8 over 17 because it should be x over r. Go ahead and fill out the rest of this table. I hope in the back of your mind you're already starting to recall this from geometry and start thinking about, oh, this is kind of like opposite, adjacent, hypotenuse. Hopefully that's starting to become apparent to you. Again, we'll get to that in a future concept. Okay, I want you to pause your video, and I want you now to try this problem on your own. Remember, start by plotting the point -3, -4, drawing your angle, and finding your x, y, and your r value. Be sure to always simplify any fractions that you can simplify. So for example, for tangent of theta, I had -4 over -3, which is just a positive 4/3. Undefined functions. Some functions, whenever we try to find the value of sine of theta or cosine of theta, we get an undefined value. So these are going to be our quadrantal angles, the ones that are multiples of 90. So in my first column here, I have 0 degrees, 90 degrees, 180, 270, 360. And I've given you the x and the y values for those angles already. Now what I haven't given you yet is r. It really doesn't matter what r is. Let's just use r equals 1 for this example. Okay, this is going to be something I'm going to talk through, and I'm going to put some stuff in these squares that I'm eventually going to erase or replace. So just put your pencil down for now, and I'll let you know whenever you need to write something down. Okay, so for our first box, we're going to write the value for sine of theta. In this case, theta is 0 degrees. So sine of 0 degrees would be y over r, which would be 0 over 1. Moving on to cosine of 0 degrees, that would be x over r, so it would be 1 over 1. Tangent of theta would be y over x, so we have 0 over 1. I'm going to fill out the rest of this table the exact same way, and then we can talk about the answers. Again, don't write any of this down yet. Okay, looking at all of these values, we have some of them that are undefined. Recall that a value is undefined if, for example, you're dividing by 0. So these are the functions that are undefined. The rest of them are defined as either 0 or 1. So everywhere that I have 0 divided by 1, I'm just going to put 0. And everywhere that I have 1 divided by 1, I'm going to put 1, or negative 1. Some of these will be negatives. Okay, so I replaced all of the red ones with UND, which stands for undefined, and the rest of them I simplified. This is what I would like you to pause and write down in your table. All right, so now we're going to apply that table here. In this example, we're going to find the 6 trig functions for angle theta in standard position with a terminal side through -3, 0. So here's my angle. I know you don't see a triangle, but it's just collapsed. So our x value is -3, our y value is 0, and our r value is technically 3 units long because it's this section right here between the origin and our point. If you wanted to find the r value using the equation where we do square root of x squared plus y squared, you could, but that's our r value. Okay, I want you to go ahead and fill out your answers here for the 6 trig functions. So we find that 2 of our trig functions, cosecant and cotangent, are undefined, which means you can't take cotangent of that angle. We don't get a real number answer. We're going to do a quick reminder of how to rationalize denominators because we're about to come to some concepts where we need to do this. So if a denominator of a fraction contains a radical, it's considered irrational, and we have to rationalize it using this method. Just a note, most calculators, especially this one right here, will do all of this for you. So if you've got that calculator, great. If you don't, you're going to need to know how to do it by hand. If after this portion, if you're still having trouble, then I want you to find the bonus video that I have linked for more help. Okay, in our first example, 1 over square root of 2, what we're going to have to do is we're going to multiply the top and the bottom by our denominator, which is square root of 2. This is essentially just multiplying by 1, because square root 2 divided by square root 2 is 1. So go ahead and multiply across. We get square root 2 over the square root of 4, which we can simplify the square root of 4 to be just 2. All right, on the next one, I'm going to start by writing that as square root 5 over square root 3. And then we're multiplying the top and the bottom by the square root of 3. So we get square root of 15 over square root of 9, and the square root of 9 is just 3. So now these two answers are rationalized because the denominator does not contain a radical.